Hi, my name is Joshua Vann, and I'm going over my Excel's worksheet. Question one, we started out doing uh, was our body movements for humans in miles per hour, and we took and used this equation in order to get our total miles per hour speed of body movement, and then we took and broke that or use that information and put it into a pie chart of percentages so we could see what our the percentage of miles per hour of our body movement based on where we are relative in the galaxy. Then we took and put it into a bar chart so we can actually see the miles per hour and a little bit better scale in order to see exactly how it is. Then we took and used the universe zoom app to see, based on scientific notation, how big stuff is in the universe or based against the universe. The zoom app was another way to see scientific notation. It put a picture to each item that would tell the size of the object. It displayed measurements from really small to really large by using the slider at the bottom of the page. If I was still on the equator, I would be rotating at 1,037 miles per hour, or in scientific notation, 1.037 times 10 to the third power miles per hour. As we do not feel like we are moving, but we are moving slow compared to the local group speed, measurements can be relative to multiple things. We measure when we are cooking, sewing, moving around, even in steps. If someone has a Fitbit or Apple Watch, grades, IQ, and much more. We use measurements in everyday life to describe or communicate how things work and try to relate it in scientific notation. The E is the base of 10 for measurements in large and small quantities. E plus is large numbers, and E negative is the small numbers, like bacteria. If you have a power of 0, it is just the measurement of 1. And if you have a power of 1, it is the measurement itself. Using scientific notation gives a way to shorthand really large and small numbers. In question 2, we showed skewed information, and we took and put this into a bar graph and showed the difference in the skewed numbers in the y-axis. The first one was Clinton years versus Bush years and unemployment rate percentages. If you look at the first bar graph, it looks a lot more skewed because they started the y-axis out at 5.175%, and this made the graph look like there was a big difference. But if you started the graph at 0 and went up from there, there wasn't as big of a drastic difference. Then we moved over to bowlers. We done the same thing. We took the bowler score and put that into a bar chart. And when we put it in the bar chart, we took and could see that the scores, if we start them out at 105, that there was a big drastic difference between the scores. But if we start at 0, the difference between the scores became a lot smaller. Then we uh, took and looked at the contributors for an arena funding, and we took and had a diagram that showed how much it was in $1,000,000, and then we put that in a percentage. And if you can see the difference between the percentage and the actual funds, it shows a drastic difference in what was actually paid. And then we took and done the same thing for percentage of sales. uh, Whenever you take and use the different types of pie charts, it shows uh, different different information and has it to where there's stuff is shown in a different way. Reporting misleading information will help give inaccurate data to persuade others into doing something. Uh, Giving the information in a manner help cover up or make numbers look better or worse. When the data is scaled differently, it will look different, but when it is starting where the data should, it will look skewed, especially if the axis is not starting with 0. I measured the graph for Kartra as you showed us to do, and it showed the data can be measured by finding areas of a chart and comparing it. Not all graphs are as they seem. Data can be measured wrong by not getting a good sample or by accident by not labeling it correctly. I know the different I know after completing this assignment, I will look at graphs differently by watching the axis of them and what they are reporting to see if it actually matches the graphs. Then on question 3, we took and looked at the figures of Americans with high blood pressure, type 2 diabetes, and a combination of either, and obesity. And then we put those into a Venn diagram. In one of the Venn diagrams, we took and showed it in percentages. And then in the other Venn diagram, we showed it as millions. The population is the Americans, and the data of our sample is the types of health issues. The data comparing obesity, type 2 diabetes, and high blood pressure. The number of Americans are 206. 206.1 without the health issues in millions. That is being compared to the rest of the health issues. When looking at percentages, 3.1% is obese. Type 2 diabetes is 0.1%, and high blood pressure is 7.2%. That is the only health issues, all separate. The rest are obese with type 2 diabetes of 0.1%, type 2 diabetes with high blood pressure at 0.9%, and high blood pressure with obesity 16.1%. The middle number is with all three health issues at 8.5%. Since I live in the state of Arkansas, it has more obesity than most Western states. I noticed on the map from the other page, the Western states are less obese, while most of the southern states are more obese. I think it might have to do with altitude, environment, and weather. The more active you are, the better chance of not having these types of health issues. All right. On question 4, we took and uh, looked at the heights of Army recruits in inches, and we took and we found the range, the median, the mean, the standard deviation, and the coefficient of variation. And we put that into a plot chart. And then we took that information and put it in order so we could find the quartile 1, the median, and the quartile 3. And then we put that into a box and whisker. And then we've done the same thing with the heights and inches of mall shoppers. We found the range, the median, the mean, the standard deviation, the coefficient of variation, and put that into a plot chart and into a box and whisker. The data being closer gives a strong correlation between samples. If the data and the further between the sample data and the further apart is the weaker correlation. The coefficient of variation checks how accurate the standard deviation is compared to the mean. The standard deviation is comparing data set to the average. It will get the standard deviation from the mean. Then you know if your data has outliers, and the distance back to the standard height in this case. The height of the Army recruits average mean is about 74 inches and the median is 72. The mall shoppers average is about 59 inches and the median was 60 inches. The box and whisker plot ranges give quartiles and will show where most of the data is and the beginning to end numbers. It will look skewed compared to the actual median numbers. The median on the box and whisker matches the mean and average numbers matches the mean and average numbers more. I don't know if that was an error or if the mean is actually the number in the middle of a box and whisker plot. The spread of the data is the range of the number used. Box and whisker plots are easy to see if the data is skewed because it will be either to the left or the right and not symmetric. Each height in our data is different because of the area the data was collected. The mall has more genders mixed up, and the Army has a dominant gender of most likely males. This will skew the data because the samples are not the same genders, causing the spread of data to be different. Then we went to question 3, which was the sleep patterns of Duke University scholars. And the mean was 6.7 and the standard deviation was 2.03. And we used a bell, we put the information into a chart and it gave us a bell curve. and the first standard deviation is in the blue, second standard deviation is in the pink, and third standard deviation is in the green. And we used this formula and just double clicked and used it to get all of our information all the way down. We also took and copied and pasted this this chart as we were instructed. The changes in the numbers of hours of sleep are compared to the mean. The sleep time was 6.7 hours. That is where the highest point is on the bell curve. Is the normal normal distribution. One standard deviation is 31.4% on each side, which is about 68%. Second standard deviation is 13.6 on each side, which is about 95%, and the standard deviation is 2.1% on each side, which is about 99.7%. My z-score is above the mean because I like to get my sleep and my family, and I try to stick to a schedule so we do not get sick or overtired. Having 3 children can wear you out, so I try to get what sleep I can. 7 hours of sleep is usually the most I can ever get. The measure of distribution of the median American income is about $49,445 and does not have the mean on the graph. The average household is not normally distributed because incomes change and does not always stay the same, and it is a small sample of incomes. Not everyone is included. The chart is skewed right because most of the data is to the left for the chart. The outliers would be income of 256 million or negative, but people usually do not have a negative income. Mean is the average household, the data sampled. Median is the middle of the data sampled, and the standard deviation is the difference between the mean and the data is away from the average. And then on question 6, we took and used a quadratic equation and used it to use the information of the X and the Y, the X being the input and the Y being the output, to find the sales and profit for this company. And we put it onto a chart and it made a parabola. And the initial investment of the y-axis or intercept is negative because you have to make a product before selling it and gaining a profit. The bottom of the graph where it is at 100 sales being the vertex of the quadratic equation, the minimum before he started to make profit. The break-even point is where he did not lose any money or gain any money. He starts to make a profit. He has to sell 203 items before it changes. He has to sell 260 flamethrowers to make a profit of $95,000. When starting his business, you have overhead you have to account for before making any money. You have to pay for the product, possible rent, or building if you own it, cost, and other errors. Once the product starts selling, you will eventually break even and start making a profit if your product has a good amount of consumers buying it. That is why some businesses never make it past the break even, because their product does not make the profit they need to keep it going. Thank you, and this was my Excel report.